we will understand the flowchart thinking, which makes the process clear and easy to remember. The three techniques we will cover are forward selection, backward elimination, and hybrid step by selection. The section one, why forward selection why attribute selection is necessary. So when we analyze feedback data, we may have many attributes like attendance, mark, department, lab rating, and teaching scores, comments, and more. So not all of them help in predictions. Attribute selection help us remove useless features, improve model accuracy, reduce complexity, and speed up computation. So selecting the right attribute is very important. So forward selection. So let's look at forward selection. Thinking of this starts from zero. Flowchart style step. The start with an empty features set, which is as equals to empty set, and train a basic. Then we train a basic model. Then repeat the cycle. Try adding each remaining features one at a time, and then measure improvement in performance, and then choose the feature that improves the model the most. So the decision, if improvement is acceptable and the feature repeat, and if not, we stop. The final feature set is S. This method builds a model step by step like climbing stairs. Now moving on to the backward elimination flowchart. Now first the flowchart style step, we start with all available features. So S is equals to all features. Then we train the model by repeating the evaluate importance of each features. Then we find the least useful features, that one that contributes the least, and then by checking it, the check if removing it as acceptable decision. So the decision will be, if removing it does not harm performance, we will be removing it and continuing it, and if it harms the performance, we will be stopping. And the final features of set is whatever remain in S. So this method works like pruning a tree, cutting off weak branches. So moving on to the section 4, which is hybrid step by selection flowchart. So this combines both forward and backward methods, starting with an empty set. Uh, in forward step, trying adding the best new features. If it improves the model, add it. And in backward step, if all features already are added, and if any features become useless, remove it, then repeat. Forward is adding and backward is removing. So in this method is flexible, usually gives better results, and because it allows adding good features and removing bad ones later, it is a good method to be applying. So now when to use which? So use forward selection when you have many features and you want a simple model. Use backward elimination when you start with all data and computation is manageable. Use hybrid when you want the best balance and you expect feature interaction. So forward selection starts with nothing and keeps adding. Backward elimination starts with everything and removes. And hybrid does both. So using flowchart style thinking, we make the process easier to understand and apply in the feedback analysis. And we can also see from this diagram what are the steps and the main features, or the iterations of the methods of forward selection, backward, and hybrid. So in forward, it is start with the set says, which is empty. Here we have all available features, and here it start with set, which is empty. So we train model using S. We train model using S. We choose the best fee. Here we evaluate all features by adding each one, usually as identify the best feature. So improvement better than the stopping value. Here we remove the value which is not required, and here we see the significance. We go forward and backward, adding and removing. So this was all about question number 18. The next question we will be doing the last question, question number 19 of the internal paper. Thank you so much.